Hello everyone, and welcome to your video which is going to tackle the big question, what is a trig identity? So before we get too far into the world of trigonometry, let's stop here and look at a simple identity. 5 equals 5. Such a simple identity, you probably wonder, why do I even have to learn this? Well, good point. Only because it makes it very easy. This is an identity because you have two sides of the equation that are set equal to each other, and it is a true statement. So that's what makes it an identity. It could get a little bit more interesting if I were to write this. This is also an identity. 5 equals 3 plus 2. This is a little bit more interesting than this one, although not much. But it meets our same requirements. We have two sides of the equation. They are set equal to each other, and it is a true statement. When we talk about trig identities, all we really have to do is stick some trig functions in there. So here is a very popular, very useful trig identity that happens to be true. Sine squared theta plus cosine squared theta equals 1. It's dealing with trig, which is why you have sine and cosine in there. And it is an identity because it is a statement where the two sides are joined by an equal sign, and it is true. Now, this looks intimidating. Sine squared theta plus cosine squared theta equals 1. You might wonder, how do we know that that's true? What does that even mean? Well, now we have gotten to the exciting part of this video. So let's take a look at a unit circle. So hold on just a moment. So there's my graph. And here's my unit circle. Now, my unit circle is not perfect. It is not a perfect circle. And I'm going to further mess it up by drawing a not very precise angle there. But we're going to say that this is a 30-degree angle, or if you prefer, pi over 6 radians. It is a 30-degree angle, and we are going to use this to learn where in the world this comes from. And you might recall from some earlier videos that we know that this vertical distance right here is the length of this line is the value of sine of whatever our theta is. So in this case, sine 30. And this distance right here from the origin over to where that perpendicular drops, that is cosine of this particular angle of, in this case, 30. And if we want to, just for fun, we could calculate this. So I'm in degrees. You don't have to be in degrees. You could be in radians if you so desired. I don't care. Just make sure that you know whether you're in degrees or radians. I'm going to calculate the sine of 30 degrees, and that is going to give me 0.5. And I'm going to calculate the cosine of 30 degrees, and that is going to give me 0.866. About, right? There's going to be a little bit of a rounding error, which we pretty much always get in trig, so we get used to it. All right, so now we have our unit circle. We have our theta at 30. We know that our sine, which is this vertical value here, is 0.5. And we know that our cosine, which is this horizontal value here, is 0.866. All good so far. We still don't know where this came from. So let's think about another of our favorite mathematicians, Pythagoras. If you recall, Pythagoras wrote a very famous theorem, a squared plus b squared equals c squared. where A is one side of the triangle, of the right triangle, B is the other side of the right triangle, and C is the hypotenuse of the right triangle. So let's take a look at how this compares to this. So one side of our triangle is sine. So we can write sine squared theta plus the other side of our triangle, which is cosine. So cosine squared theta equals our hypotenuse squared. And our hypotenuse, in this case, we know is 1. How do we know it's 1? Well, because this is a unit circle. That's the whole point of a unit circle, is that your radius is always 1. So we would have 1 squared. So that means that sine squared theta plus cosine squared theta equals 1. And that is our identity. Now, let's put some actual numbers in there and see if we believe that this is true. So sine squared theta is going to be 0.5 squared, and our cosine theta is 0.866, so we will square that. And let's do the math and see if it works out. So 0.5 squared is 0.25, and 0.866 squared, with a little bit of a rounding error, gives us about 0.75. And you will see that 1 does indeed equal 1. That is how we know that this is a true identity, where this side of the equation is equal to this side of the equation. And this is going to be true for every theta, because it is true for every right triangle, that a squared plus b squared equals c squared. Now, before I let you go, I just want to point out one thing. I want you to see how this is written. So we are writing it sine squared theta. That is really the same thing as if I were to write sine of theta quantity squared. Those are totally the same thing. Mathy people usually like this one. So this is the preferred one. Preferred. But they are both equally correct. You cannot say sine theta squared without the parentheses, however, because like in this case, instead of being sine 0.5 times 0.5, it would be sine of 30 squared, which is the sine of 900, which if you stick that in your calculator is 0. And that is not what we want. So if you're going to write sine theta squared, make sure you have the parentheses there so that you first figure out the sine of theta and then square it. That's the only way that the math works. All right, so that is what a trig identity is. It is an equation where one side is equal to the other side, and we got some trig functions thrown in there.